I want to let you see how good you are with understanding intuitively what these values are. So I'm going to ask you the following questions. Remember, A naught, the intuition is what is the average value of f of t. And your A sub 1, the intuition is how much cosine at that fundamental frequency gives the best fit. And A sub 2 says how much cosine of twice the fundamental frequency gives the best fit. And B sub 1 says how much sine of the fundamental frequency gives the best fit. We're calculating all these things completely independently of each other. Every single value of the Fourier series is calculated independently of any others. And so on. So just as an example here, here's a regular square wave. It goes between +4 and -4. And I want you to guess what these things are. So Charles, give me a guess of what A naught is for this. Your intuition, what is the average value of this thing?
0.
Yeah, it's a good guess. It looks like it's even top and bottom. And let's see, Joe, tell me what your guess is for A sub 1. How much cosine of the fundamental frequency would you fit in there?
Would it also be 0?
So,
oh no, sorry, 5.
Yeah, that's good. That's a good guess. So that would be, you're saying it'd be something like, that. So your guess here is 5. And Ben, what would your guess be for B sub 1? How much of the sine of the fundamental frequency would fit in here?
So that will be 0.
Right, because sine is odd and this is an even function, so that would be 0. Here's the exact values. The exact value is 0, 16 over pi, and 0. Now 16 over pi evaluates to 5.09. So my point is that your just rough guess is phenomenally close. I didn't try to twist your arm at all. Is phenomenally close to what it actually is. You've got a really good intuition for what these values are. Here's another one. Let's do this thing. Same idea. So Connor, what's its A naught?
0.
And because that was so fast, I want you to tell me it's A sub 1 too.
Sine. Or whatever.
A sub 1 is how much cosine of the fundamental frequency gives the best
then
value.
0.
That's right. All right, so that's also easy. So I'm going to keep on you for the last one. How about B sub 1? Yeah, I needed to tell you the height of this. So let's say it's 1 and -1.
Maybe like 1.5.
Okay. So I think you're dealing with what Jonathan gave last time. And of course, the exact value is 0, 0, and it is 4 over pi, which is 1.27. So, I mean, that's still within 25% of the correct answer, and that's just off the top of your head. Here's something quite different. I worked this out exactly, and it was a bear. This is not a cosine wave. This is exactly a semicircle. So a sine or a cosine, it has a non-vertical angle when it crosses, whereas a semicircle, I didn't draw this particularly well, but you can see what I'm trying to say. That's a little bit better. Okay. What would you guess here? For a semicircle, it's perfectly vertical at those crossing points. What would you guess it's A naught to be? Phil.
Still 0.
Yep. A sub 1. I want to need to tell you how high it is, I guess. So let's say it goes up to between +1 and -1. What would you guess?
So, I mean, it looks similar to the cosine, so we're still going to have A, but it's since it's like straight, it'll probably be a little bit more. So I'd say like 1.1 or something, 1.2.
Okay. I'll split the difference with you, 1.15. And then how about B sub 1? Also, Phil.
So it'll probably be pretty small because it's almost a cosine wave. Maybe I'll
Well, is it even or is it odd?
Oh, is this an even? Is it an even one?
It is.
Okay. So then it'd be 0.
It's 0. Yeah. The way I drew it probably isn't 0 because it's not perfectly even, but it's meant to be. Here's what it is exactly. It is, of course, exactly 0 here and 0 here. And this is an interesting one. This is, if I draw it in for you, still haven't drawn it very well, but it's something like that. It turns out to be about, it turns out to be exactly pi over 2, which is 1.57. But even for this thing, which is really doesn't have much intuition behind it at all, you're still easily within 30% of its exact correct answer. Now here's a harder one yet. But this, I think, this one is going to bring together a lot of different ideas for you.
Sorry, can you explain to me how you guess these values for A sub 1 or B sub 1 or whatever?
Sure, that's the intuition over here. So A sub 1 says how much cosine of omega naught gives the best fit. So you're trying to imagine if you were to graph A sub 1 corresponds to cosine of the fundamental frequency. So the fundamental frequency is something that has a period of this. And so all I'm doing is in the background, I'm just trying to guess what would if I was to graph a cosine here so that it has as much area that it overestimates and underestimates, what would it look like? And for this cosine, I'm kind of guessing that Phil guessed that it's maybe about 1.15, and it turns out to be exactly 1.57, but it's close. For this one, how would you graph this as a sine wave? You'd say it's kind of like that, right? And so that turns out to be exactly 1.27. Now, let's say you didn't recognize that this is an odd function, and you thought, well, maybe there is some non-zero amount of A sub 1 that I could draw. So you try to draw your cosine wave, and your cosine wave would look like this would have the correct fundamental frequency. It's the distance, the time period of your red is the same thing as your time period of your green. But I mean, this you could just see, this underestimates it over here, it overestimates it over here by the exact same amount. And so you should want to underestimate and overestimate. You can see that no matter how much or how little this thing you put in, it's going to do the wrong thing. You can't put in any amount of this even function and have it fit well to the underlying function you're trying to model. Does that answer your question? Dom? I think that was Dom.
I just don't understand how we're guessing 5 from that first example.
On the first example, over here, is that your question? Your audio is breaking up, so just say it one more time.
That's my question. How we're guessing 5 for a sub 1?
Yeah. So he's saying, well, let's see. It goes up and down 4. So let's see. I'm going to guess it's probably looks something like that.
So the top of that square wave is 4?
The top of the square wave is 4, and the bottom square wave is -4. So we're going to guess it goes between +5 and -5. And in fact, it goes between 5.09 and -5.09. And that's our guess.
Okay, I think I get it now. Because we're trying to guess the peak to peak of the cosine where it would bisect it at the where it crosses the x-axis.
What we're trying to do is guess how much, so that we're overestimating it here and we're underestimating it here, and we want to make our overestimate and underestimate the same, so it best fits it. Let's do another one, unless you're really not sure about what we've done so far.
No, that's fine. We can do another one.
Let's do this one. This is shoot. One, 2, 3, 4. I'm going to try to. So here's my line along 3. Here's my line along my grid line along 2, and here's my grid line along 4. And that's our thing we want to plot. So once again, I'm going to have you guess what A0 is, A1 is, and B sub 1 is. So Dom, since you let us off last time, tell me what your guess for A0 is here.
Is this a symmetric function?
Uh-huh.
So 0.
So keep in mind, what does A sub 0 ask? What is the average value of your function? So what's your average value of this function?
I don't know.
Okay, so sometimes it's high, sometimes it's low. If this was your bank account, sometimes you've got $3 in your bank account, sometimes you've got $4 in your bank account, sometimes you've got $2 in your bank account, and your bank account keeps changing between +2 and +4. What's your average value in your bank account? Dom?
1.5.
So if you've got an average of $2 to $4 in your bank account, then your average value would be 1. That's surprising.
3.
If this, 3, right? That's your average value. So so A sub 0 is 3. So reread this. This is important. A sub 0, the intuition is what is the average value? Just like A sub 1 is how much of your fundamental of your cosine gives you the best fit. I think some of you might have looked away might have had your attention split for part of this lesson and missed that. And obviously, if you miss that, then everything else goes down pretty fast. Okay, so Sabine, now I'm going to ask you, what is our A sub 1, which is how much of the cosine of the fundamental frequency? What's the fundamental frequency? Remember, the fundamental frequency is how long does it take to repeat? So we're going to say how much of a cosine that has that time period, which of course is the same as this time period. Maybe that's a little bit easier to see. How much of our fundamental of our cosine waveform do we have there? What would you say?
I would say 2.
So let's try it. So we'll draw 2 here. Let's see, that would start us off here, and then it would go down here. Whoops.
So would you want to shift it with your average?
Yeah, you do need to shift it with your average. And so maybe it's easiest to draw that first. So now that we've got your average taken away, we have this without your average. And so now when we try to add 2, let's see, that'll go up to here, right? And that'll look something like that. That doesn't look like a very good match. That's partly because my drawing is so bad, but that's also because it doesn't really fit, right? You don't want to have something that goes up and down.
So would that make this function odd? Therefore,
Right.
we don't have an a sub 1, so it'd be 0.
That's it exactly. That's it exactly. But Sabine, just finishing it through, asking the question that you wanted to give, how much b sub 1 does it have?
Including the average.
Not including the average. So remember, we subtract these things away.
Okay.
Because if you don't subtract it away, you're drawing it down here.
I think it'd be roughly 1.
Yeah, it's a pretty good guess. 1 would give you something that looks like, 1 would probably, my guess is actually no, that is a pretty good guess. I think 1's a pretty good guess. I think 1 would overestimate it a little bit slightly everywhere. So I would say it's probably a little bit less than 1, but that's a pretty good guess. And let's see what it is exactly. I've got to look it up. It is, your guess is 1, and it is exactly 3, 0, and 8 over pi squared. The math gets a little bit nasty, which turns to 0.81. So not far off, within 20%. Here's one. Any questions on this one? This really shows how you build up your Fourier series out of the parts. Here's another one. I'm not going to graph it. Instead, I'm going to give you the formula for it. F of t is equal to 2 plus 3 cosine of 6t. So who's next in my list? Preston, what's the A naught for this waveform?
2.
Yep. Tank, what's its A sub 1?
Three.
That's it. And Charles, what's its B sub 1?
Not sure.
So take a look at what B sub 1 represents. B sub 1 is saying how much sine of the fundamental frequency is in there. So now take a look at this function. How much sine of the fundamental frequency is in there?
So 0.
0. Yeah. And of course, the exact answer is exactly that.